Hello and welcome to this NFER webinar, Interpreting Outcomes from Standardised Assessments. I hope you can hear me okay and you should be able to see the first of our slides on your screen. I'll start by introducing myself. I'm Nicola Ward and I'll be hosting the session today. I'm joined here by my colleague Jemma Coulton, one of our specialist content developers in NFER's Centre for Assessment. For those of you not familiar with NFER, the National Foundation for Educational Research, we've been supporting teachers and policymakers benefit from robust assessments for over 70 years. Our assessment expertise rests on a solid foundation of research, ranging from piloting and evaluating new assessment models to researching effective test development, marking, administration, analysis and reporting methodologies. In today's 30-minute webinar, Jemma will be taking you through the various outcomes from standardised assessments and how they can be used to monitor attainment and progress. If you have any questions, please do share these in your comment box as we have set aside time at the end for a short Q&A. So, without further ado, I will hand over to Jemma.
Great, thank you. So first off, I thought I would talk a little bit about why you should use standardised assessment. A standardised assessment enables benchmarking of individual and cohort performance against national averages. It also helps teachers to identify strengths and areas that might require additional support. It gives results which can be meaningfully compared across subjects and between years to monitor attainment and progress. So just looking at this slide, you can see how standardised assessments might be helpful for your classroom.
Okay, so what are standardised assessments? A standardised assessment, firstly, has been trialled with a large nationally representative sample of pupils. Now, what does this mean? This means that the trial that takes place before the tests are published takes place with a large number of pupils, usually around 1,200 per test, and with a large number of schools. And it's important those schools are from a range of regions, a range of school types, and a range of Key Stage 2 performance bands. Now, the reason this is important is that the data from this trial is used to produce the outcomes that teachers use in schools. So it's important that this data is meaningful. We obviously can't trial the test with every single pupil in the country, so we assume that if we use a large sample, and this sample includes a range of school types, it is representative of how pupils will perform as a whole. A second important aspect of a standardised assessment is that it is trialled at an appropriate time in the school year. Pupils perform differently at different times in the school year, so it is important that the test is trialled at the same time the live test will be taken. It's also important that the test is trialled under the same conditions as will be used for the live tests. So this includes things like the timings and also how much support pupils are given when taking the test. And all of this means that the data from the standardisation trial can be used to reliably compare pupils against the national average through standardised and age-standardised score outputs, which we'll talk a little bit more about as we go through this presentation. So the outcomes that you get from standardised assessments differs depending on which assessment you're using. In this webinar, I'll go through a range of different outcomes, including raw scores, scaled scores, age-related expectations, standardised and age-standardised scores, and then at the end, I'll talk a little bit about how you can use question level information to get more information about your pupils. So the first outcome we'll talk about is raw scores. Most written assessments will produce a raw score, and it's the easiest type of outcome to calculate. Basically, it is the number of marks a pupil has achieved out of the total number of marks available on a test. Now, though this is the first outcome you will get from a test, it's not very useful in comparing pupils' performance between one test and another or over time. And this is because raw scores do not take into account the difficulty of the questions in the test or the performance of the pupils more widely.
Okay, so here is an example of raw scores. If your class sits the grammar, punctuation and spelling test, and after marking you find that the average raw score for your class is 9 out of 20, so around 45%. It may appear that your class has performed poorer than expected on the test because they've achieved less than half marks. However, this does not take into account how well pupils did nationally. If the average raw score in a national sample was 7 out of 20, or 40%, then your class has done quite well on the test comparatively. Raw scores on their own don't tell you this because they don't take into account how well pupils have done in the national trial. Debbie scores 15 out of 20 or 75% on a reading test, but scores 10 out of 20 or 50% on a maths test. So at first glance, you may think that Debbie is doing better in reading than maths. They've taken 2 tests, both with the same number of total marks, and they've achieved more marks in reading than maths. However, it is worth noting that the raw scores don't take into account the comparative difficulty of the 2 tests. They assume that each mark is equal. So it could be that the questions in the maths test are harder than those in the reading test, and Debbie is actually doing equally well in both subjects. However, raw scores on their own can't tell us this. So looking at the examples on this slide, you can see how raw scores on their own aren't the most helpful tool for measuring attainment over time. So there are several solutions or different outcomes you can use that may give you more information about your pupils. And I thought it would be useful at this point to bring in the national curriculum assessments because they use a similar method. So national curriculum assessments report their outcomes as scaled scores. And the reason for this is that the outcomes from national curriculum assessments are compared year to year. However, the difficulty of the test may vary year to year. So raw scores on their own are not very helpful, as we've just discussed. So raw scores are converted onto a common scale to allow comparison between the different assessments every year. And this converted score is called a scaled score. Standardised score, which you may have heard of, are one type of scaled score, and we'll talk a little bit more about those later in the presentation. Now, because the same scale is used, outcomes between different tests can be compared, regardless of difficulty, because the difficulty of all the questions on the test have already been taken into account. And as I've outlined, for both Key Stage 1 and Key Stage 2 national curriculum assessments, results are reported as scaled scores for this very reason. So while we're talking about scaled scores and national curriculum assessments, it will be helpful to talk about the expected standard. In national curriculum assessments, a score of 100 is not the average score of pupils taking the test. In fact, the average score tends to be slightly higher than 100, i.e. more than half of pupils may achieve a score of 100. On national curriculum assessments, 100 is the expected standard. And this expected standard is set out by the Department for Education and is intended to reflect that a pupil is working at an expected standard according to the curriculum. So as you can see, this is different than an average. This isn't the average score of pupils who are taking the test. This is an externally set expected standard. The number of marks that gains a score of 100 was initially decided by a panel of teachers in 2016 based on an in-depth review of the curriculum and the scrutiny of question level statistics. By looking at the curriculum and these question level statistics, these teachers could agree on what performance on the test indicated that a pupil was working at the expected standard. In subsequent years, the number of marks that equals a score of 100 has been decided through data from trialling to make sure that the standards are maintained year on year. So this expected standard set out by the Department for Education is a type of outcome measure called an age-related expectation, i.e. it is a measure that reflects whether or not pupils have achieved a certain level as would be expected in line with their age. NFER Summer Reading and Mathematics tests for Key Stage 1 and Key Stage 2 contain a measure of age-related expectations, which indicates how well pupils are performing against the programme of study for their age group, which is set out in the curriculum. This outcome was developed through several judgmental exercises involving a large number of teachers. And here is an example of the tables indicating age-related expectations, which are included in the teacher guide for those tests. As you can see from this table, pupils who score between 0 and 19 have been classed as not achieving age-related expectations on the test. Those who score between 17 and 29 have achieved age-related expectations on the test, and those who score between 27 and 37 show high achievement on the test. Now, you may note that there is an overlap between these categories, and the reason for this is that we felt that pupils who were on the borderline between two categories, it wasn't very useful to determine which group they should go in based on one single written test. And so we felt that particularly for those pupils, teachers should draw on their wider teacher assessment to determine which category was most appropriate for that pupil. Okay, so moving on to standardised scores. Again, standardised scores are a more useful measure of pupil attainment than raw score. They are in fact a type of scaled score. So they involve converting raw scores onto a common scale. Usually, tests are standardised so that they have a mean or an average of 100, regardless of the difficulty of the test. So the difficulty of the test is taken into account in the standardised scores. Because this same scale is used across different assessments, it can help you to meaningfully compare attainment across different standardised tests. For example, across different subjects, e.g. comparing maths and reading, or across different years, e.g. reading on a year 3 test compared with reading on a year 4 test the next year. Standardised scores are produced by looking at the performance of that large nationally representative sample who take part in the trial. And this means that the difficulty of the test can be taken into account, and it allows test takers to be compared with other pupils nationally. So how do you interpret standardised scores? So a standardised score of 100 is the average, meaning that this is the average score of the nationally representative sample which trialled the test. A pupil who scores 100 is working at the average for their age group. Now, about 2/3 of pupils will have scores between 85 and 115, and these can broadly be described as average. Pupils scoring below 85 are working below average, and pupils scoring above 115 are working above average. As you may realise, this means that a large proportion of pupils will have standardised scores between 85 and 115, so you may find it helpful to further divide this category to help group pupils and support further learning. If so, the following rough groupings could be helpful. However, it is worth keeping in mind that those pupils between 85 and 115 are all working at the average. So pupils between 70 and 84 are below average, those who score between 85 and 94 are low average, those between 95 and 105 are average, and those between 106 and 115 are high average, and as explained earlier, those who are above 116 are above average. So how do you use standardised scores to monitor progress? So this is one of the benefits of using standardised scores, is the ability to monitor progress over time. So as I've explained, with standardised scores, 100 is the average score for a particular test. If a child gains the same or similar standardised scores on consecutive assessments, they can be said to be making average progress in relation to their starting point. For example, if a pupil achieves 98 on their Year 3 test, they are working at about average for their age group. If the next year they then achieve 101 on a Year 4 test, they are again working at about the average for their age group. They have therefore made average progress for their starting point. However, if a pupil's standardised score falls by a considerable amount between two consecutive assessments, they are making less than average progress in relation to their starting point. For example, if a pupil achieves a standardised score of 105 on a Year 4 maths test, but then the following year achieves a standardised score of 95 on the Year 5 maths test, the pupil can be said to be making less than average progress for their starting point. And in this case, a pupil may need extra support or to be monitored more carefully. And conversely, if a pupil's standardised score goes up by a considerable amount between two consecutive assessments, they are making more than average progress. This may occur if a pupil is catching up and has previously been below average. So this graph is one of the reports that you can produce using NFER's analysis tool, which is available free with our NFER assessments. What it is showing is a class or a cohort's progress between two assessments. Here, the Year 3 Summer Reading Assessment at the bottom of the screen and the Year 4 Summer Reading Assessment on the left-hand side of the screen. The line through the middle shows average or expected progress. As you can see, a child at the very bottom of the graph achieved a standardised score of 70 in Year 3 summer reading, and then achieved a standardised score of 70 again in Year 4 summer reading. And that pupil, although working below average, is making expected progress for their starting point. Similarly, the pupil at the very top of the line scored approximately 140 on their Year 3 summer reading test, and then again about 140 on their Year 4 summer reading test. So they are working above average overall, but they are making expected progress for their starting point. And as you can see from this graph, most pupils fall along the line, which is showing that they are mostly making expected progress. However, there are some outliers. For example, the pupil indicated by the arrow had a score of approximately 121 on the Year 3 summer reading, but then got a standardised score of around 109 on the Year 4 summer reading assessment. Now, as you can tell from those figures, their standardised score has fallen between the two tests. And this may indicate that this pupil, though performing above average or at average for their age, is making less progress than expected between Year 3 and Year 4 based on these assessments. So when using standardised scores, how do you know if the progress made by a pupil is better or worse than expected? Now, this adds a layer of complexity to using standardised scores, because in order to be able to tell whether progress made is better or worse than expected, we need to be able to use confidence bands. And these will be provided with most standardised assessments. And what they give is the range of scores in which a pupil's true score lies. And this takes into account the fact that one test can only cover some of the curriculum. For example, there are aspects of the curriculum that cannot be assessed in the written test. And also that a pupil's performance on a single test may not reflect their true ability. For example, they may have had a poor night's sleep or have just come back from holiday, and they're not really showing what they can do in maths on that particular day. So the confidence bands is a range of figures around the standardised score in which we have a 90% confidence that the pupil's true score will lie. And at the bottom of here, you'll see a table, which is what is included in our NFER test teacher guides to help teachers calculate this confidence band. So to use an example, if we had a child who scored a standardised score of 70, to get their confidence band, we subtract 4 and add 5. So their confidence band would be between 66 and 75, and we have a 90% confidence that their true score falls within that range, regardless of the fact that this is a single test or that it's a single test on a single day, which may not reflect their true ability. So how do you use confidence bands to determine whether a progress made is better or worse than expected? When two standardised scores are being compared, for example, between summer Year 3 and summer Year 4 tests, if the standardised scores are different, but the two confidence bands overlap, then there is no significant difference between the scores. And in this case, the pupil is making expected progress. However, if the two confidence bands do not overlap, then there is a significant difference between the scores. And in this case, the pupil is either making significantly more or significantly less than average progress. I have a couple of examples to illustrate this on the next slides. Firstly, if you have a pupil in your class called Harry, and Harry achieved a standardised score of 100 on a Year 3 maths test. The next year, Harry then achieves a slightly higher standardised score of 104 on a Year 4 maths test. Just looking at his standardised scores, you may feel that he has made better than expected progress because his standardised score has increased. However, if you take into account confidence bands, we know that Harry's true score is between 95 and 105 in Year 3 and between 99 and 109 in Year 4, as you can see from the figure at the bottom of the slide. And as is quite clear from this figure, the confidence bands overlap. And we can therefore say that there is no significant difference between his scores and the tests, and Harry has made average progress. Another example is Zara. Zara achieves a standardised score of 91 on a Year 3 maths test. Confidence bands indicate her true score is between 86 and 96. Zara then achieves a standardised score of 103 on her Year 4 maths test, and confidence bands indicate her true score is between 98 and 108. Now here, the confidence bands for the two tests do not overlap, and this means the two scores on the two assessments are significantly different. So this suggests that Zara has made significantly greater than average progress compared to her peers. So age standardised scores. As the name suggests, age standardised scores take into account the age of the pupils. In most classrooms, the oldest pupils may be up to 12 months older than the youngest. And this may lead to older pupils achieving slightly higher raw scores than younger pupils on average. Age standardised scores compare pupils to other pupils in the national sample of the same age in years and months. So, though a younger pupil may gain a lower raw score than an older pupil, they may have a similar age standardised score. Age standardised scores can be helpful in allowing meaningful comparisons between pupils within a school, particularly earlier in schooling where younger pupils may attain lower standardised scores, even if they are doing well compared to other younger pupils. However, it is worth keeping in mind that two pupils with the same age standardised score are not necessarily showing the same attainment. They are simply working at a similar level, taking into account their age difference. As with standardised scores, the average age standardised score is 100. A pupil who achieves a score of 100 can be said to be working at the average for their age. So here is an example. Simon achieves a raw score of 26 on the Year 3 reading test, which is a standardised score of 105. Simon is 8 years, 8 months and is one of the oldest in the class. His age standardised score is 98. As you can see, his age standardised score is slightly lower because it's taking into account the fact that he is one of the oldest. However, another pupil in your class, Talia, achieved a raw score of 17 on the same test, which is a standardised score of 93. So she's comparatively working at a lower level than Simon. However, Talia is one of the youngest in the class, aged 7 years, 8 months, and her age standardised score is 96. So as you can see, when age is taken into account, Talia is actually performing similarly to Simon. However, as I mentioned earlier, it's worth noting that their attainment is actually probably slightly different in terms of what they understand. They are just working at a similar level when their age is taken into account. So finally, I'm going to talk a little bit about question level analysis. Whole test outcomes are very useful for understanding pupil attainment and progress on an individual or cohort level. However, there's a lot of other information that you can gain through standardised assessments. Investigating performance on specific questions may give information about particular areas or skills that pupils are struggling with, and this could help plan future teaching and learning following the test. The NFER analysis tool allows teachers to investigate their pupils' performance on NFER tests on a question-by-question basis, and the following slides, which I'll just briefly run through, show how this can be useful. So here is a screenshot of the NFER analysis tool for a particular test. As you can see, the question numbers run across the top column, the top row, 1, 2, 3, 4, 5, and so on. On the left-hand side, you'll see average of group, and this is the row that is currently highlighted. And this shows you the mean score for the pupils in your class for each particular question. The row that's currently highlighted is the average of the standardisation sample. So in the large-scale trial that was conducted prior to publication, this shows the mean score of the pupils in that trial. The row below shows the difference between the average of your class and the average of the standardisation sample. And the analysis tool will automatically shade specific cells in green or red, depending on if they are above 0.2, if they are more than 0.2 above the mean of the standardisation sample or less than 0.2 below the standardisation sample. So basically what that means is you can look at how your class is performing compared to the standardisation sample and whether they are performing significantly better or significantly worse on specific questions. And how that might be helpful is looking at the programme of study or the focus at the bottom. So these are linked to the National Curriculum Key Stage 2 test frameworks. For example, 2D is the code for inference. So you could look at how well your pupils are doing on particular areas or particular skills. Thank you, that's everything I had. Hopefully that was helpful. Are there any questions?
Yeah, that's brilliant. Thanks, Jemma. We have actually had a few questions come in, which is great. I know we're tight on time, but we'll try to get through them all. And if we do run out of time, we'll follow up with our answers over email. So firstly, I've got a question in. Why do we only have age-related expectations in our summer tests and not in others?
That's a really good question. So age-related expectation relies on having a standard to be able to compare pupils to. Now, the curriculum has a programme of study for each year and shows what people should be expected to know by the end of the year. There isn't, however, a shared standard for what should be achieved by the end of the autumn or by the end of the spring term. And in fact, in different schools, different content is taught in different orders. For example, in the maths curriculum, it may be that some schools teach certain content in autumn, while other schools teach that content in spring. It wouldn't be fair to tell pupils that they are not working at the expected standard, not because they are struggling in maths, just because they haven't been taught that content. So really, we can only do age-related expectations for the summer test because there is an agreed standard which pupils are measured against that's set out in the national curriculum.
Perfect. So we've got another question here for you, Jemma. How do we access the analysis tool, and is that the same one that shows on the scatter plot that you've just shown?
Yes, so the NFER analysis tool is a tool which is included free with all of NFER assessments for Key Stage 1 and Key Stage 2. If you purchase any of those assessments, you will then get login details to the online site. And yes, the scatter plot that was included is one of the various reports that can be produced. It can also automatically calculate standardised and age-standardised scores by entering your class's raw scores. But that scatter plot that I put up on screen earlier, you can compare any two assessments. So you could put Year 3 reading and Year 4 reading, or Year 3 autumn reading and Year 3 spring reading. So it's a really helpful tool for monitoring progress in your class.
Perfect, great. And if standardised scores are a scaled score, why does a scaled score of 100 on a national curriculum test mean something different than a standardised score of 100 on other tests?
Yeah, so I think this is something that causes confusion. They are both scaled scores, but the STA scaled score is different than the scaled score that creates standardised scores. So they are doing different things. So for a standardised score, the most important thing is the average of the sample, which is why that's set at 100, so that you can compare different tests across years or across subjects. You know that 100 is the average of the pupils in that sample. However, for the Department for Education, the important measure is the expected standard. And so this is set at 100. There is a mean on those assessments. There is an average score, but that isn't what the 100 represents. 100 represents something different here. It represents that measure of age-related expectations, that expected standard. So they are both scaled scores, but they are working on a different scale, and standardised scores and Department for Education scale scores are not directly comparable. 100 on one does not mean the same as 100 on another.
Great. We've had another question. Can we get a copy of this PowerPoint? Yes, absolutely. We'll follow up with this PowerPoint and send it over to everyone so you can share it with your colleagues. We'll also be uploading this webinar to our website so that you can watch again or share again with our colleagues. And if you do have any questions, I think it looks like we've run out of time for today, but if you do have any other questions that you'd like to put to our assessment team, please feel free to send them over to assessmenthub@nfer.ac.uk. And there's also some more information on how you can get more information about NFER tests on the screen as well. So thanks everybody. Have a wonderful rest of week. Bye.